Hi NeuroTechX, my name is Kaylin,
I'm Han.
and we are Mint, the Multifaceted Innovation and NeuroTechnological team. As a team, we've worked together on possible projects that could innovate and have a great impact on the neurotechnological field. We are split into three sub-teams. The Neural and the App Dev team work together on the Open Challenge.
And the electrical team, we work on the Fix Challenge, and today we're going to present to you our most recent accomplishments.
For the NeuroTechX Fix Challenge, we made an EEG collection system that gets the EEG signal from the scalp using the electrodes. Then the signals is passed through the PCB board to amplify and low-pass filters. It is then passed through the Arduino board for analog to digital conversion, and finally it is digitally notch filtered by the Python code and then displayed on the screen.
Rather than working with microvolt signals, we decided to create an amplification and active filter circuit. To determine the best op-amp for our EEG, we found 4 reasonably priced amplifiers with a high common mode rejection ratio and created a preliminary PCB to test all of their frequency responses. In the end, we chose the AD620 op-amp for a 1000 gain amplifier and the OP281GSZ for the low-pass filter. They were both chosen for their excellent cost efficiency and response to noise.
We have implemented an active second-order low-pass Butterworth filter in hardware. The filter attenuates all frequency components greater than 100 Hz, isolating the relevant frequency band for EEG signals and preventing aliasing from occurring when we perform analog to digital conversion.
Last year, we used a physical 60 Hz notch filter integrated into the circuit. However, it was not able to function properly and made the circuit very bulky. To remedy this, we decided to instead implement a 60 Hz notch filter via code. To do this, we improved upon last year's visualization Python code and ran a loop that removed all entries of the Fourier transform around index 60. However, due to a scaling issue with our graph, the actual index removal was at 27 to 30. But this is not a noticeable issue and the 60 Hz noise is still removed.
This year we decided to move our circuit from a breadboard to a PCB. This change allowed us to reduce noise from the breadboard and the dangling wires, giving us a cleaner EEG signal for future processing. Our compact design this year also allowed us to stack 2 shields, one of which was our amplifier and filter circuit onto the Arduino. As you can see in the video, our design is very compact, fitting nicely onto the microcontroller. The design choice in moving to a PCB also gives our machine a more finished and professional look.
This is our board. It's basically 3 parts. So we have the Arduino, Leonardo, the ADC shield, and then our amplifier and filter on the top. So if you take a closer look, you can see there's 4 channels, and then these are the 4 inputs, and then we have a differential amplifier and a filter. And then the outputs come along here and into the ADC shield down here. And that's our board.
For the EEG signal, we used the PCB that we made, an extended ADC shield, a Leonardo Arduino board, which totally cost about $278. Besides that, we have cables to connect the board to the power supply in the lab and to the laptop for sending code and showing the signal on the screen. We also use gel electrodes to get the signals from the scalp.
Look, she's dead. actually some
Oh
kind
look, it's a blink.
Yeah,
How do you guys feel about this?
wow. Sad. There's actually some kind of thing happening at Mentha, so
I think that's just like a connection problem.
okay, the FFT finally caught up.
Okay, now we see the noise.
Like, don't move. Oh.
So over this year, we have met our board, and the problem with the board right now is that we usually connect from this to the electrode and to our brain through many different wires connecting together, which introduces a lot of noise. So we hope that next year we will make like a box and then put it on a headset or using snap connector that will prevent noise. Furthermore, right now we are using the resistor about 50 ohm, which only gives us the gain of 1000. We expect to make it larger so that we will get more accurate signal.
The digital notch filter does help reduce the size and complexity of the circuit compared to last year. However, because we reused the code from last year and just added the filter code to it, it may somehow reduce the speed of the signal processing. It takes us about 10 seconds now to see the real-time data, so we will need to learn a lot more about signal processing programming.
We surely had to face many challenges, especially since many senior members left, and most of us, including me, are new members this year. So we had a lot of new stuff to learn, especially in making the PCB. Initially, only Anthea really knew how to make it, and the rest of us, especially me, were quite lost. So we looked up online videos, self-learning, and asked each other a lot of questions, and eventually we could make that awesome PCB board. So it was quite a fun and meaningful experience. I could learn a lot more about EEG circuit, filters, the amplifiers, especially making the PCB, and had a lot of hands-on experience.
Hi there, my name is Allison and I'm a third-year electrical engineering student on Mint. Having been on Mint for the past 2 years, it's been a great experience seeing how far we've gone from our first prototype. This year, I've gotten to learn about PCB design and design my own PCB using Altium. I learned more about EEG signal processing and the pros and cons of software versus digital filtering. I had a lot of fun being able to work hands-on on our final prototype of our EEG machine.
Hi, I'm Anthea. I'm a fourth-year electrical engineering student, and this is my second year on Mint. I had a lot of fun this year seeing our EEG system improve from what we had last year, watching our team progress from breadboard prototyping to professional-looking PCBs. My favorite part was definitely having the opportunity to assemble the PCBs that we designed and seeing the final product.
Hi, my name's Kyle, and I'm a first-year member of Mint. This has been a challenging year for me because I've gone from knowing next to nothing about circuit design and EEG systems to making Altium schematics, signal processing, real-time visualization of data in Python, and a lot of quality testing. Overall, it's been a very fun year for me and it's given me a lot of insight into electrical engineering.
Hi, I'm Tony, the confused-looking guy in the red shirt. I'm a second-year electrical engineering student, and I really enjoyed delving into creating analog circuits with Mint. I worked on the initial amplifier design as well as testing and troubleshooting the filter. I learned a lot about PCB design, from schematic to soldering, and using both hardware and software to process noisy signals.